Hi guys, this is Mrs. Gastler, and in this video we're going to talk about drawing motion diagrams with constant acceleration. And more importantly, we're going to be adding in some arrows for acceleration. And that's what really sets these apart from the ones that we've been drawing. All right, so previously in our notes, let me pull those back up, we've looked at what acceleration meant and then how to draw some acceleration in there. So we have getting faster where our arrows get longer when you're going in the positive direction here, negative direction there, and slowing down where our arrows get shorter and our dots get closer together like this. What we want to do in this set of notes is we want to add in, we want to show the acceleration in our arrows here, okay? So what we're going to add is some acceleration arrows. And what acceleration arrows show, they show how the velocity changes. How the velocity changes, okay? And so let me see if I can't get to draw this correctly. So let's take an object that's going in the positive direction and speeding up, okay? And it looks like this. Maybe, and this one is longer. And if I did this exactly right, which I probably didn't, let's be completely honest, what I can do to show my acceleration arrows is I can compare. So my first arrow is this long, and look, this right here is how much longer that arrow is. And if I do this, if I were perfect, this would be exactly the same amount longer, which it looks like it kind of is. And then here, oh, this one's just a little bit too long. I should have made that one shorter. But this length right here is my acceleration arrow, okay? And so what I'm going to do is I'm going to write that above here. So there's the acceleration that I'm adding, okay? So my arrows are getting longer, and I'm showing that it's accelerating by adding that on top of here. Let me label these, but not with that pen, okay? These right here, those are the acceleration arrows. Okay, so we're going to look at some examples and we'll see how the acceleration arrows can look different, and then we'll kind of think about what's going on here. So let's do the next example. Okay, so here we have a car that is speeding up from rest, and it says that the direction of the acceleration is in the same direction as the velocity. This one actually works pretty well with what I just drew. I don't know why my pen can't draw a line right there. So if I kind of follow the car here with my dots, okay, and I draw my arrows like so, you can see that my arrows are getting longer. And to add my acceleration arrows in, I'm going to estimate. And if you had another piece of paper and you wanted to do what I did on the first one, that's how long the first arrow is, and it's just that much longer. This one's not very even either, is it? It's not so bad. Okay, so my arrows are getting longer each time I draw one. So I'm going to add an acceleration arrow. I'm going to try and make it about the same length as I saw that I was adding. And every time it gets bigger, I'm adding one. Once it stops getting bigger, like if it started going at a constant speed, I would quit adding acceleration arrows because we didn't have any acceleration arrows in Unit 2. Okay, so constant velocity, no acceleration arrows. All right, so now I've got a car that is slowing down, and here it says the direction of acceleration is opposite to the direction of the car's velocity. So this one's going to look a little bit different. All right. So remember we talked actually we didn't talk a whole lot about it. In constant velocity, in Unit 2, we talked about how velocity is a vector, and there's all sorts of cool stuff that you can do with vectors. And one of them is that you can add and subtract them. And if they're in the same direction, you would add them. And if they're in opposite directions, you would subtract them. And when you subtract vectors, you end up with a smaller vector, which is what we're going to be doing here because we've got this good long arrow. And then our arrows are getting shorter and shorter because our object is slowing down. Okay, so there's the first length. And look how much shorter it is here. That right there is my acceleration arrow, but because my arrow got shorter, my arrow is going to point in the other direction. And there it is again. They're not exactly even, and that's okay. So I'm going to show my acceleration pointing in the opposite direction. So we should make a note, and we'll put it right here. When the velocity and acceleration are in opposite directions, that means the object is slowing down. That says slowing, you can tell, right? Slowing down, okay? When they're in opposite directions, they subtract from each other, so the object is slowing down, even if it were the other way. So if, well, actually that's going to happen in another example, so we'll just wait until then, okay? All right, so last one on this page, we've got this ostrich running, okay? It is speeding up to catch its group, but notice which direction it's going. So this time, my arrows are going to point in the other direction. So I've got my, whoops, I guess he's starting back here. That's fine. All right, so here's my ostrich going along, okay? So he's going, I mean, he's starting out kind of fast, and then he's going even faster. Ostriches run like really fast, 30 some odd miles an hour. It's pretty fast for a bird, okay? So on this one, when I add my acceleration arrows, which way are they going to point? Are they going to point to the left, or are they going to point to the right? These are kind of even. Oh, that's almost the whole page. All right. So they're going to point in the same direction that we're adding. So they're getting bigger here, so I'm going to be adding onto the acceleration, so they're going to point in the same direction, okay? So here, when they're in opposite directions, we're slowing down. If they're in the same direction, the velocity arrows and the acceleration arrows, if they're in the same direction, then the object is speeding up. Okay, so you can look at a diagram pretty easily. Now, you guys are pretty good at looking at the velocity arrows. These arrows that we've been drawing on our motion diagrams are velocity arrows, and they just get longer or shorter, and you guys are pretty good at knowing what that means. And so now we're just adding in those acceleration arrows. So they go in the opposite direction when it's slowing down. They go in the same direction when it's speeding up. Okay, so here we have a bike. Okay. Here's our bike. It's participating in a 20-mile bike race, and now he's getting home. And so speed is decreasing, okay? So the direction of the acceleration arrows should be in the opposite direction. So let's put 0. It doesn't really matter where 0 is. So we're going to start here and there and there, and there's our dots. And so we have a long arrow because, what's his name? Tom. Tom is going fast. And then Tom is slowing down because he's tired. He biked 20 miles. I don't know if you've ever biked 20 miles, but you're usually tired at the end, unless you've been doing it for a long time. And so if I estimate how much longer my arrows are each time, or how much shorter my arrows are, then I can draw my acceleration arrows based on that. This time, remember, they're going to point in the opposite direction because Tom is slowing down. So this arrow has to get shorter, so we're going to be subtracting from it. Here it's going to get shorter, and here it's going to get shorter, okay? And so those are my acceleration arrows. When I draw acceleration arrows, I usually only draw them in the middle dots, and the ones on the end I just kind of ignore. I don't know what's going to happen after that, so I leave those off. If you need to draw a motion diagram and show that something is slowing down, you need at least 3 arrows so that you can include at least 2 acceleration arrows, okay? So the minimum arrows here is going to be 3. All right, so now we have a ball rolling down a ramp, and it's increasing its speed as it goes down the ramp, because that's what happens when you roll down a ramp. Okay, so our arrows are, again, getting longer. So which way are our acceleration arrows going to point? What do you think? Here's my number line. Okay. If you picked that way, then you are correct. Okay, they're going to point that way. Are they going to be very long acceleration arrows? No, not so much. That's what they might look like right there. Okay. If I had an object that was going at, this is going to be some bonus notes here. Okay. What if my object goes speeds up and then goes at a constant speed? What would that look like when I have a combination of motion? Okay. So let's think about that. All right, so my object here, maybe it starts over here. Okay, maybe that's how fast it's going, and then it's going faster, and then faster. My arrows look pretty terrible today. And then faster, and then maybe it goes that constant speed for a while. And so that arrow is the same length, and that arrow is the same length, and that arrow is the same length. Okay, so in this case, it's only speeding up right here. Speeding up, and then right here, it's going at a constant speed. So where do my acceleration arrows go? Well, they only go where it's speeding up. So I'm going to start over here. So it's getting longer. Which direction are my acceleration arrows going to point? That way, that way, that way. Don't pick that way. That's the wrong answer. And if you said this way, you are correct. And so I only put them in the middle. It didn't gain anything from here to here, and so I don't put an acceleration dot there because those are the same. Okay, so this is where it was accelerating, and this is where it's going at constant speed. Okay, so now you are totally ready to do the practice on the next page. Thanks for watching.